All right, by request, I am going to record from now on. I'll say it one more time. From this point on, at least for identities on this page, from this point on, if you see sine 2 theta in our future questions, you have permission to rewrite it or convert it into 2 sine cos without proving anything, and vice versa. If you see 2 sine cos, you could turn into sine 2 theta if it will help you with your proofs. Here is the cosine version of it. I'm going to prove this to be true. Left side is cos 2 theta. And of course, the right side, just get into a habit, 1 minus 2 sine squared theta. Here we go. Using compound angle formulas, this is the same as cos of theta plus theta, which is, and you remember off the top of their heads? Cos, is it a plus or minus? Good. Oh, you guys are practicing. Cos minus sine, which I am going to convert some way. What do you think I'm going to do? Remember, the goal for identities is to try to make one side look like the other. Here I have single cos and a cos. On the right side, I have a square. What do you think might be a good idea? So how about rewriting this as squares? And so we have sine squared, right? I need 2 of them. And I need to convert cosine squared into a 1 somehow. Any thoughts? Grade 11, Kinda? Pythagorean identity. Please recall that if I have sine squared theta plus cosine squared theta equals a 1, well, cosine squared theta is equal to this. And so on my left side, I'm going to take my cosine squared theta and convert it to that. Done. Nope. I'm simply showing you that anytime I see a cosine squared theta, I can rewrite it as 1 minus sine squared. So this transferred over. Not transferred over. This was changed into that. Yes, Melody. Nope. I want to show you where it came from. But just like I was saying, without explaining anything, you can convert these two interchangeably. Same thing here. If you see cosine squared theta and you rewrite it as 1 minus sine squared, I will understand it. You don't need to do this. You do not need to show me this at all. That's I guess the beauty of identities. It's already established. So think about it as like Pythagorean theorem. Everyone accepts it as truth, at least in this world. And so same thing here. If you use it, I'll understand it. Question so far? Yes. I have a subtraction of sine squared and another subtraction of sine squared. So I'm subtracting 2 sine squared from the. Okay.
I get it now.
Okay, keep chewing on it. The last two that I want to set as true, and so you can use anytime you want, are these. These are called even odd identities. And as opposed to proving it with another identity, you can simply prove that these two are true from either graphing it or using cast rule. So we haven't gotten to the graphing chapter yet, but it makes sense if you looked at it from a grade 11 level. But I'll try to prove it from cast rule. Consider this. If I have sine of a negative angle, so let's pretend, just for example, right? That's a negative angle. Agreed? This is my y, and that's my r. My y is a negative value. Let me look closer. My y is a negative value. So sine right? What if I had sine of my positive, but the same angle? So same angle, but it's on the positive side. Sine of x would be positive y over r. In other words, negative sine theta or sine x is equal to negative, right? That's why these two are equal. So if you ever see sine of a negative value, sine of a negative angle, you can actually rewrite it as negative of sine positive angle. They are two equal values. As part of an identity, you can do this without having to explain to me why you did it. You can do it just on the fly automatically. Does this look familiar? This is actually odd identities. I mean, odd and even functions. This is the same as saying, remember that from chapter 1 or chapter 2, even versus odd? Cosine is an even. Cosine is like f of negative x is equal to f of x. In other words, there is a line symmetry. Think about it graphically. Cosine is right? Remember that from grade 11? Line symmetry. That's why this makes sense. But graphically, same thing. If I have cosine of negative angle, what's cosine? Adjacent over hypotenuse. Cosine of a negative x is equal to, or negative theta is equal to, adjacent over hypotenuse. Cosine of x, it uses the same x value. So cosine of x is equal to x over r. They are both going to be the same. So I'm just trying to show you another proof that explains why you can use this interchangeably. No problem. This one's particularly useful. If a cosine is using a negative angle, you just rewrite it as a positive and you can forget about that negative value. It's useful. All right. That is essentially, there are more identities that I could teach you, but it seems like we're going to avoid those. Maybe on day 2, I'll show you some things that the textbook might, or sorry, that universities might assume that you know. Please turn the page to the sheet that has all these identities. Would you add these two onto your sheet? Please add this and this onto your sheet so that you know it's a thing that you can sort of put to the grade. Here. So if you take a look here, the double angle formulas are just underneath your compound angle formulas. If you have a compound angle, in other words, x plus y angles, you can rewrite it. But if the two angles happen to be exactly the same, you can rewrite it like this. Okay, so please note, these come from it comes from the Pythagorean identity. You may also want to add the fact that sine of negative x is the same as negative sine x. Cos of negative x is equal to positive cos x. Those are all part of your identities. Okay. Yeah, so couple of rules you might want to follow just to help guide your thoughts when you're proving identities. This is what I tell my grade 11s. So if you were in my grade 11 class, you may have heard it. Number one. A couple of things. Please note. I'm going to add some notes here. What you might want to do is because the Pythagorean identity uses sine and cosine, it may be easier to convert everything into sine and cosine. So even tangent, you might want to convert it into sine and cosine. It might make life easier for you. And number two, the only other, I think, helpful advice I can give. What was it that I wanted to say? There's one more. I forget. It's probably along the lines of don't be afraid of fractions. A lot of the times when you turn things into fractions, the denominator, like things start to cancel each other out, look pretty good. I'm going to try 3 examples with you. That's on the left of this sheet, numbers 1, 2, and 3, and you will see what I mean. I hope that you will explore. Do not be afraid to explore. Sometimes as you try this, try that, suddenly it sort of pops up and works out and it comes together. This section really tests your creativity and your perseverance. The longer you stick to a question, either you won't see it and then you come back to it and then you see it, or you won't see it and then you won't see it and then you come back to it and then you see it. I don't know how many times when I was doing this in high school where I didn't see it that night of, but because I was in a term school, I still had another day. So I went back the next day after sleeping and I actually figured it like clicked. Trig Identities was the main unit that taught me that your brain actually grows neurons when you sleep. So if you didn't know, your brain processes everything you experience during the day through deep sleep. Stage 3, stage 4 sleep. So after you work your butt off and your brain hurts, make sure you get good sleep because your brain actually grows extra grooves. Okay, you become less smooth brained for those your teenage lingo or whatever it is that you guys use. You guys understand what I'm talking about, right? Here we go. Do your best to make the left side and right side equal. Start with the side that seems more complicated. To me, I think the left side looks a bit more complicated because it has cotangent. So I'm going to start by turning that into sine versus cosine. Here we go. Ugh. Left side. Cotangent of theta over sine 2 theta, and the right side I'll write later. This is the same as cos theta over sine theta, all over sine 2 theta. I could, oh, sorry, that's supposed to be a theta, by the way. Yes. Cotangent is 1 over tangent. Here. If not, use this identity. Yes. On the right side, I don't see 2 theta. Everything has been converted to just regular theta, which means sine 2 theta. Use your double angle formula. Sine 2 theta is going to be 2 sine theta cos theta. Remember that identity? We just proved it. We just proved this one to be true. Maybe I'll use some color to highlight where this is going. And then I'll use another color. Really? Huh. All right, whatever. And what does that turn into? I have a fraction divided by something. So divided by this, which is 1 over. So proofs like that. It's been so long since it's been so long since I've sort of experienced seeing and learning trig identities for the first time that I forget where you might be, what parts might be confusing. So please raise your hands and let me know like where you don't quite understand. Josh? Cos, this one? Yeah. That's a multiplication. Because it's a fraction divided by something, so I decided to rewrite it as an expression, a different expression. All right, now it's your turn. I'm going to start number 2 for you, but I'd like you to sort of see what you get. 10. Sorry, you had a question? Pardon? Yes. So all that's left with it is 1 in the numerator, sine times 2 times sine, which happens to be the right side. Okay, cosecant. So left side. Now I looked at the right side, and yes, I do see a cosecant. I don't like that. I am going to rewrite everything in terms of sine and cosine again. So this is 1 over sine 2x, and the right side is cosecant x over 2 cos x. I'm going to rewrite this as 1 over sine x divided by 2 cos x. And now I need to make these two sides equal to each other. What would you do? Again, you're trying to make the left side look like the right side and vice versa. So start to manipulate things or change things to make it fit a little bit more and more. Every single step, it should have a purpose behind it. Mason, I hope you're paying attention. Oh. Yes, Adam. Multiplying. So this one on the right side? Okay, sure. So I am going to change this into. That was interesting. Yeah, sure. Now what? Yeah. 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 Right. It should be familiar to you if you know your identities. Now, not yet, of course, because you're still sort of seeing it for the first time. If you remember, 2 sine cos it's a double angle formula. This can be rewritten as, which is the left side? Oh, sorry. There it is. Yep. Of course, you can do it, approach it in any direction you want as long as it's mathematically sound. It doesn't matter whether you start on the left side or the right side. It's good. I recommend you starting out whichever side seems more complicated. Of course. So you're saying, instead of doing it this way, can I just say this? Absolutely. Not a problem. Yep. No, I just did, I made this equal to 1 over sine x times 1 over 2 cos x. Because that's 1 over sine x divided by this is the same as 1 over x multiplied by the reciprocal. Yeah, so that the denominator is now 2 sine cos. Yes, ma'am. Can we solve the left side? Yeah, you could have left this and you could have solved this first. No, the left side, I didn't touch it. I just got to 1 over sine 2x. And then the right side matched with that left side. So we just left it. Oh, well, okay. I think it would be easiest to actually work on both sides because I don't want to turn this into cosecant. But if you did, it would look something like this. You separated it into 2 fractions that are multiplying and turn that into there. Yep, you can do it that way too. As long as the left side and right side are equal at some point, you're good. Which brings us to number 3. Now people will start to have their own opinion on which side looks more complicated. I would venture that this does look complicated. It does. However, I noticed that these are compound angle formulas. Maybe if I rewrite this, somehow, somewhere, I'm going to get some cosine squares. It's up to you to figure out where to start. So I will, I don't want to suggest anything to you this time. I want to see if you can choose your own path, choose your own adventure. Okay. And see if you could at least get somewhere in the next 10 minutes. And then I will quickly do the answers and set you free. Focus on this question first. You'll get a chance to see the video. Everyone, I'm hoping the goal of our practice is not to develop a better memorization skill or a better memory. Your goal is to be able to think. Interesting. I've taught my 2.5-year-old this morning. This is what thinking means. And so we point to our heads together now. Gosh. All right. All right. I'm gonna do it. Oops. Where is my whiteout? Okay. Uh, okay, here we go. Oh, but hey, we got some squares, right? Right? Yeah, yeah, and the middle two happen to be exactly the same. Look, sine x and a sine y, a cos x and a cos y. Sine x and a sine y, cos x and a cos y. They are the same product, so they will cancel out, leaving me which now brings us to what the heck am I going to do? Yep. Take the sign away. Oh, sort of. We could use a double angle formula. Unfortunately, these are squares. It doesn't fit the double angle formula properly. Jaga? Oh, okay. Well, in trig identities, try it first. Try it first because it's hard to see how things will simplify. So you know what? I'm going to take your suggestion and we'll try it. And if it doesn't work, it doesn't work. So people don't write anything, but we'll try it. Why did you think we can try Pythagorean identity? That's it. So here's two clues. They are squares. And not only are they squares, the sign sort of disappears somewhere. Is there a way to get rid of sine squared? Yeah, right? We can rewrite sine squared as 1 minus cos x squared. And then write this as 1 minus cos squared y. So and then I will expand it, giving me 1 times cos squared y, and then cos squared x, cos squared y, minus cos squared x. That becomes plus cos squared x, cos squared y. And then Vishaka, what happens? Were you wrong? It seemed wrong, but they cancel out. Leave me with, there you go. So you got it. So honestly, okay, and then where's my little QED? My proof goes all the way to the end, so my little block is going to be right here. At least that's how I like to do it. Some people just write it right here, but I guess it's your own preference. Sometimes it will look a little funny, I admit. And sometimes it'll be harder than others. There will be some that seem harder than others because you haven't thought about it in this way or you haven't thought about trying it that way. But the identities will be popping up all over the place. Be creative. And even though you might think it might not be right, give it a shot. You never know. Okay. Yeah. On your table somewhere in your triplets, on your triple tables, there is a sheet that you are responsible for. This is what the math teacher decided on doing. It is a problem set where I would like you to do all 5 questions. Out of those 5 questions, we are going to be marking one of them. Just like last year. Notes. That's what I did. You will be evaluated on only one of the following 5 questions, but you must complete all 5. You don't know which one to mark it. Prove the following trig identities on a separate sheet of paper. Be sure to write down all steps and use proper proof format, so that's side, right side. 2 communication marks are assigned to the clarity and structure of your proof, so be sure all your steps are clear and correct. You may assume any identity is given or derived in class and found on your identity sheet. By identity, take a look at number 4 and number 5. Do you see how it's there are some other angles involved, like pi over 4 is 45 degrees. But get you to think about it a little bit. See if you can wrap your head around that. If it's Is it time already? Oh, it's time already. Everyone, tomorrow, you're not coming to school unless you have a predetermined appointment with me. On Thursday, as soon as I hear the schedule for the Remembrance Day Assembly or whatever it is, I will write it on bright stick. So you will know whether you're writing the test immediately, whether there's a short break, or you're going to write it. We'll see you Thursday. Does it matter? Wow. It is.
Don't understand how now and try something.
No, but there are clues. I told you. Look. Why did Vishaka think maybe I should use Pythagorean identity? Looking at the right side, yeah, there's no sign. So she used this version. 1 minus cosine squared x is equal to sine squared x. 1 minus sine squared x is equal to cos squared x. We tried it. So there's small clues. See you later. Oh, absolutely. Sorry, I didn't do that for you. See you later. I'm not here Friday. Yes. Also, please report the lesson Friday because I see we're doing 4 lessons and I don't want to miss that. Yeah, well, it's a large portion of it.